Attendance. Your teeth are cold?
Yeah.
That could be a rough morning, yes.
Yeah, it was just a little cold.
Well, warmer than some places.
Shoot.
Yeah.
Bang.
You don't understand the rage that fills inside me when you say that.
Why?
She doesn't like fun.
I take requests, that's all I'm saying. Okay.
Yes, I am. E-A-I-S-N.
All right. Before we get going today, ladies and gentlemen, a couple of reminders here. Number one, you are going to need goggles for tomorrow and Thursday. Now, if you bought them the other day from me, I still have them. They're in the box if you left them here. If you didn't buy them from me, I still have the box here. You can buy them tomorrow or Thursday. And then after that, I'll be returning that down to the office so that they can bill your accounts and things like that. So you need goggles. The labs we're doing, you're going to be working with some highly concentrated acids. So definitely going to need goggles. I have aprons in the back, but it might be a good idea too to bring or to wear some old clothes, because the lab that we're going to do is one that you can get stuff on your clothing and it'll eat through them. So, all right. Questions? All right. All right. Today we're going to talk about properties and changes. That's what the lab is about tomorrow as well. We're also going to take our quiz today. Atomic structure is not on the quiz. KMT, heat and temperature, classification of matter are. Those are the things that are on the quiz. If you got any questions on those, on KMT, heat, temperature, classification of matter, I'll take those now for you.
Just run through everything really quickly.
Okay, it's on heat, it's on temperature, KMT. KMT, all matter is made of tiny particles, are always in motion. Heat, measure of the average kinetic energy of matter. Temperature, measure of the sum of kinetic energy of matter, particles in matter. And classification matter, it's either an element, compound, which are substances, or a mixture being homogeneous or heterogeneous. So, anything more specific? All right, name me some changes that matter can go through. What's a change that matter can go through?
Crystallization.
Crystallization, meaning a solid can form, okay, from a liquid. What else? Sublimation, meaning that a solid could go directly to a gas. What else? Melting, meaning a liquid or a solid can become a liquid. Good. What else? What's that?
Boiling.
Boiling, going from a liquid to a gas. Okay, good. We're getting all those out of the way. A couple more we could hit. Condensation, going from a gas back to a liquid. Deposition, going from a gas back to a solid. I think that covers all of those. Okay, now what are some other changes matter can go through? Okay, that is a sign of a chemical change, and a color change can happen. Name me an example of a color change. When do you see it? What kind of matter goes through a color change?
Either like two colored things going together, or like you have like a clear thing and a clear thing and they'll come together.
Okay, all right. Anybody else got a color change that happens almost yearly?
Trees.
What? Trees and leaves. Trees and leaves change color every year, right? They go from being green and healthy to being brown, orange, yellow, falling off the tree. Okay, what else? Changes that matter can go through.
Size? Like, change of size?
Okay, like how?
Like when people lose weight?
Okay, people can lose weight, change the size. All right, good. You can add heat or take away heat from the substance. It can change temperature. Okay, good. What else? What happens to iron that is sitting out?
Rusty.
Rusting. That's changing matter, right? Rusting. What else?
Burning.
I know this. Okay, very good. Burning. Burning. That's a change. Okay, definitely a change in matter when things are burning. That's a change that's been very predominant in my house the last few days. Okay, had a fire going the last few days so that things stayed a little bit warmer, a little bit toastier in the house. All right, what else? What are other changes that matter can go through? Making yogurt, making wine, making alcohol,
Fermentation.
fermentation, and distilling. Yes, we will distill those things as well. Fermentation and distilling. Okay, alcohols or sugars become alcohols in wines and in things like whiskey and vodka and brandy and things like that. Okay, there are a lot of changes that matter can go through, and some of the ones that you named just now, ladies and gentlemen, were chemical changes and some of them were physical changes. Please remember though, a change is an action. A change is something that is actually happening. What do we call it if it's not actually happening, but it can happen? So it's not actually burning, but it can burn. What's that?
Potential.
Okay, not what? One more time, I'm sorry. I thought you said something else. Sorry. It does have the potential to do that, but if it can do those things, then we call it a what? When it's going through them, it's called a change. If it can go through it, if it can melt, if it can boil, if it can rust, if it can burn, if it can rust,
If it can burn.
actually, what do we call it if it can burn? Flammable. What is that?
Fire hazard.
That is a property.
No.
That is a property, ladies and gentlemen. Okay?
Smells really good.
So if we're distinguishing between properties and changes, changes are things that are actually happening, that are occurring. Properties are things that can happen if the conditions are right. Okay? All right, EISN, ladies and gentlemen, open it up and get to slide number 66. 66 in your EISN, ladies and gentlemen. All right, we're going to begin with defining properties. Okay? Two kinds of properties, physical and chemical. A physical property can be observed without changing the substance. Now, there is a change that happens, but what doesn't change is whatever you begin with is still there afterwards. You begin with a piece of paper, you still have a piece of paper. You begin with water, you still have water. You begin with iron, you still have iron. Changes that can be observed without changing the substance. Okay? Or I'm sorry, properties are that can be observed without changing the substance. When we put something on a balance, we will find its what? Mass. Does that change the substance? No. That is a physical property. Okay? The density of something, we find its mass and its volume. All physical properties. We don't change the matter when we're finding its density. We don't change the matter when we're finding its volume. We don't change the matter when we're finding its mass. Okay? So things like boiling point and freezing point, density and mass. Now, not boiling here. Understand this is boiling point. Because if it was boiling, what would that be? Would be a change. It would be an action. These are not actions. Okay? All right. In a chemical change, something new is created. Okay? So a chemical property is a property that causes a new substance to be created. It causes something different to be there than was before. Give me an example of all of those things that we named earlier. Give me some of them that were chemical properties. What? The ability to rust. Yes. What else? Remember, phrase it as not an action, but as something that can happen.
Fermentation.
Okay, the ability to ferment. Yes, the ability that something can ferment. What else? You gave it to me a little while ago, Najma.
Flammability.
If something is flammable. Flammable means that it doesn't mean that it is burning, it means that it can burn. Okay? So, again, being able to tarnish or rust. Something that can corrode or is corrosive. Something that is toxic. Those are all chemical properties. Things where a new substance will be created, ladies and gentlemen. All right. So what do properties have in common, whether they are physical or chemical? They both describe what can or will happen with matter. Okay? They describe what can or will happen to matter under certain conditions. If you get water to this temperature, it will boil. If you put water with this other substance, it will react. It can or will happen under certain conditions. Properties can be described as characteristics or traits. So what is the biggest difference between a chemical and a physical property? Okay, but again, that's a similarity between that they can be observed. What is the difference between them?
Physical is like more apparent.
Okay, physical is more appearance. Chemical would be more what?
Chemical, like changes through like the substance.
Okay, I'm agreeing with you, but we got to find a different way to phrase it.
Like the properties.
So physical would be more in the appearance of something. Chemical would be more in the what of something.
And their properties.
Well, but again, we're describing property, so we can't really use the term to describe it. I'm agreeing with you, but to say that the difference between a chemical and a physical property is their properties doesn't make a lot of sense, right? It isn't very descriptive. So again, I like what you said. Physical changes the appearance of things. Okay? So a physical property would be a change in the appearance or how something looks. What would a chemical be?
The makeup of them.
Thank you. In the makeup of something. In the makeup of something. Okay? In the makeup of something, ladies and gentlemen. Hang on, I gotta get my cursor back on this screen. Okay? Physical change, only the appearance. Chemical change, what is there, or the makeup. Chemical properties do not depend on how much sample is present. Some physical properties do. Questions? Anyone need more time with this slide? All right, so let's talk about changes. And again, there are two types of changes. There is a physical change and there is a chemical change. Okay? Now, in properties, it describes, or it could be observed without changing the substance, or describes how matter would react. A physical change is a change in which no new substance is created. So now we're actually doing something, but still we are not creating something new. Give me an example of a physical change. Something where we change something, but we do not make something new out of it. Cutting something. You cut a board in half, you cut a piece of paper in half, definitely cutting something. What else? Crumbling up a piece of paper. Okay? Crumbling up a piece of paper. Or a piece of aluminum foil in your lab. Making it into a stirring stick. What's that? Something, let's change that a little bit. Not disintegrating, but dissolving. Something dissolving is a physical change. So throwing salt into water and it dissolving. Throwing salt or sugar into water and it dissolving. Definitely a physical change. What are the most common ones? The ones that happen all around us on a daily basis. What? Boiling, any type of phase change. Thank you. So melting or boiling, cutting or tearing, dissolving. All of those are examples of physical changes. Notice we have made these into action words. Melting point and boiling point were the properties. Now the action of melting or boiling is the actual change. Something as being able to be cut or to be torn is a property. Actually being cut or torn is the change. And then dissolving, ladies and gentlemen. Dissolving is a physical change. All right, so a chemical change would be a change in which a new substance is produced. So you get something different, something that wasn't there before. Give me some examples of a chemical change. Rusting. Burning. We were on a roll there. We were doing really good. 2 right out of the gate, and then we came to a screeching halt. Rotting.
Sorry.
What's wrong with rotting?
No, it was just on the slide.
What's that?
They're all just on the slide.
Okay.
I was just
Now, you don't always have to be original. You could read what's there for me. Yeah, that'd be fine.
Right.
Rusting, tarnishing, burning, rotting. Something corroding or eating away at something. Okay? Now, let's go back. What happened to the aluminum foil in your lab last week? No, it did not dissolve. It did not.
Burn.
It actually reacted with the substance in there. Dissolving means that it stays the same. It breaks into tiny pieces. Okay? Sugar dissolves, salt dissolves. Your aluminum did not dissolve. Your aluminum reacted with the copper chloride, and it actually went in and it kicked out the copper. It took its place. So that now there was aluminum chloride solution in there. Okay? That is different than dissolving. Okay? That is more like disintegrating. Okay? Where it actually seems to go away. But it's not just dissolved in there. The thing about dissolving is because it's a physical change, we could get that back. Boil off the water, we're going to get the sugar back. We're not getting the aluminum back. You're not boiling off the water and getting aluminum foil back. It's gone. It's now aluminum chloride in there. Okay? So a little bit of difference there.
Can some chemical changes be reversed?
Some chemical changes can be reversed. Not a lot, but some can. For example, you could take water and split it into hydrogen and oxygen gas. We could do that. And then we could take and put a little energy into hydrogen and oxygen gas and make water back. Yes, some of them can be reversed. Most of them cannot. Okay? You can't bake a cake and then unbake it. Okay? So a lot of times chemical changes cannot be reversed. Sometimes they can. It all depends on what the actual change is. Okay? Similarities. Both involve changes in appearance. It's going to look differently whether it was a physical change or a chemical change. How differently? More so in a chemical change, but either way it's going to look differently. Both can create new properties. So again, I understand cutting something in half. What is the new property that is created about it? Different length, different width, different mass, different volume, things like that. Yes, all of which are physical properties too. Okay? Both of these are actions though. That is the important part. Whether you're talking about physical changes or chemical changes, they are both actions, ladies and gentlemen. Okay? They are both actions. All right. And again, as we said just a minute ago with Jera, most chemical changes are very difficult to undo. Some you cannot undo. Some you can. Physical can be undone. Now again, if you cut a piece of paper in half, can you undo that? No, you can't undo that. But you could tape it back together or things like that because you haven't actually changed what is there. When you burn the paper, can you put it back to being paper? No shot at all there. No shot at all there. You cannot unburn something. Okay? Again, some chemical changes we can undo, most of them we cannot. Physical will maintain some properties. A physical change doesn't always mean that the properties are going to be different. Chemical will not. Because you have something new there in a chemical change, you're going to have new properties. And chemical creates something new, physical do not. Again, that's the ultimate difference between them. That's what makes it a chemical or a physical change. Questions? You're having a bad morning, Jera. You really are. All right. Anyone need more time with the slide? Okay, go ahead. Finish up. Sorry. All right, here we go. So now we're going to just take a minute and we're going to look at the difference between properties and changes. By the way, okay, you may have learned some of this in physical science, okay? I'm pretty sure they would have gone over the differences between chemical and physical changes with you. I know I did when I taught physical science. Please remember, later on in the course, my students who are now in the second half, the second trimester of this course, are now realizing that, oh yeah, you're going to need to know this stuff later on. Okay? You're going to need to know this stuff later on when we get into things that are more complicated than where we're at right now. So that is another reason that we are going over these, ladies and gentlemen. Okay. So this part is already filled in for you. So let's just go through it. When we talk about properties, it is descriptions, traits, or predictions. When we talk about changes, they are actions happening, they are active. I believe that on the test, I will probably ask you a question to give me the difference between a property and a change in under 5 words. I can do it in 4. Property, prediction, change, action. There you go, 4 words. That's the entire difference between properties and changes. One is a prediction. One is telling you what could happen, what will happen, what can happen. The other is an action. It is telling you what is happening. Okay? What is happening? Properties are things like density, specific heat, and reactivity. Now remember, these are just properties. They could be chemical or physical. These two are physical, this one is chemical. Burning, melting, boiling, rusting, tarnishing. These two are chemical, this one is physical. Okay? Again, all we're talking about is changes in properties. Properties have known values, can be looked up. Even chemical properties can be looked up. You can look up if something will react with something else. You know, there are some days you just don't want to know, ladies and gentlemen. You just let it go by and you just move on along.
Stop. I'm curious. What is that? I'm not gonna let it go.
What?
What is that?
I have no idea what it was. It happened in the hallway. I have no idea.
No, that thing you just threw away.
That was the remnants from the lab that we did last week, the aluminum copper chloride
Last
lab.
week.
Last week.
Last week.
Is there something that I don't understand about that phrase? You remember we did the aluminum and the copper
I know.
chloride
It's been
lab?
sitting here for like 400.
How many hours is that?
Like. I don't
Like-
know.
like-
I was gonna make
like-
an estimated
like-
guess.
I'm-
and then decide right
I don't know where you're going with this, Brinley, but okay.
96.
All right. You can even look up chemical properties. This table over here, ladies and gentlemen, is called solubilities in water. And this table says that if you mix aluminum with each of these things, it will tell you if it will dissolve or not. If it will dissolve, ladies and gentlemen, that means that there is no reaction with this substance in water. If it will not, if it is an I or insoluble, that means that it will react with that substance. It will create a precipitate that will settle out to the bottom of your container. A precipitate that is one of the 4 signs of a chemical change. So you can look up the boiling point of water. You can look up the density of water. You can look up all of these things in the handbook. Well, you can also look up chemical properties as well. Okay? So properties are known values and they can be looked up. Changes can be predicted and looked up as well. Okay? The differences between the two, ladies and gentlemen, properties are traits or predictions. Changes or actions are happening. That is the biggest thing. And you can take any property, basically, and almost make it into a change. Even the property of mass. You could change the property of mass by changing the size of your sample. Cutting something in half. Separating things.
So wait, how do they know this back then?
How do they know this back then? How do they know what?
Like, did they just like watch this happen? How do they figure it out?
Yeah.
Basically by doing the same things over and over again and studying it. So, for example, we did the density of a liquid in here. We found the mass, we found the, not of a liquid, of those blocks. And what they found over time is no matter what size sample you took, you always got the same number. They found that when water would boil, under these conditions, it always boiled at the same temperature. Okay? They literally find melting point by taking a small sample of a solid, putting it under a microscope and adding heat. And as soon as it starts to show any signs of melting, boom, that's the melting point.
So they did that for every single.
Like that was their life.
Basically, well, it wasn't one person who sat and did all this.
Well, yeah. but
Over
like,
time, they collected this data from people working with different things,
that's
different
kind of
elements.
sad. Like,
Why?
an entire group of people's life was dedicated to figure out common sense.
Figure
Like,
out
whoa.
common sense.
Things
Whoa.
boil.
Whoa.
Okay, obviously.
Okay, things do boil, but at the time, did they know that things all boil at the same temperature? No. And they had to look them up. They had to test them to find things out.
You said I have to look him up.
What's that?
Yeah, they pulled out their laptop.
Pull out their laptop.
No, but there were references that they had long before there were.
They had references.
They had
They pulled
references
out their
long
rock,
before
they pulled out their rock
laptops.
phones.
The idea didn't help us any because they just kind of made it down.
Here's the other thing, and I will tell you this.
More help.
When you go back and look at the history of science, the history of chemistry specifically, there was a long period of time where scientists didn't share information. Did not. Why? Because it was believed that if you were practicing chemistry, some believed you were practicing witchcraft. So you would be ostracized if you were practicing witchcraft. So a lot of chemists would study things and didn't know that. How do you think they found out that certain medicines work? They had to make them and test them. Who did they test them on? Themselves. So a lot of times they either blew themselves up in a lab or they poisoned themselves trying to come up with a new medicine. Okay? Now, they didn't write things down. So unfortunately, somebody else would come along and do the same thing. And it wasn't until, I don't know, the mid 1500s that scientists finally started to share information. And then they would collect all these things and they would put them, not on the internet because they didn't have it back then, but they would put them into reference books that they would then share. Okay? Years ago, this is how doctors did medicine too. Doctors used to have to go and look up, hey, this case of where this person had these issues, this is what the disease was. They had to study it. That was the only way they could find it out. Well, the only way they could find out the properties and the changes was to actually go through them with matter and see what happened to them. But the nice part about chemistry is once you find it, you should be able to repeat it. You put two things together, they react. Whenever you put those two things together, they should react. Okay? So,
You have like
All right.
a burning headache. Hold on.
I got it.
So, here is another way of looking at properties, ladies and gentlemen. This is different from chemical and physical. This is called intensive and extensive. Okay? Extensive because I'm right here. Extensive properties depend on the size of the sample. How much of the sample there is determines this property. So, for example, the containers of water on the cabinets in the back compared to the pitchers of water on the counter. The amount of water in there, if it matters for the property, that makes it extensive. So, for example, the mass of water in the big containers, the volume of water in the big containers. Those are extensive properties. There aren't a lot of extensive properties. Most properties do not depend on the size of the sample. Some do. Mass, length, volume, width, height. Okay? These depend on how much sample is there. Then there's what is called intensive. Intensive properties do not depend on the size of the sample. These are the properties that are more useful to us in identifying things. Why? Because if you're looking at identifying if that substance is water or alcohol, the fact that its boiling point is different no matter how much of it is there means that we can use that to help determine what it is. The fact that its density doesn't change no matter how much of it there helps us to identify or use that to determine what a substance is. It is not that extensive are not useful, they're just not as useful in identifying things as intensive. By the way, every chemical property is intensive. Every single one of them. Yes.
Why is there no pressure at the bottom of the ocean? Is that it?
Because of the weight of the water on top of you.
And is that density?
That is not density, that is pressure. Okay? Pressure is kind of like temperature. Temperature is dependent on how much energy there is around you. Okay? Some days there is more energy, some days there is less. Depending on how deep you go under the water is going to determine how much pressure there is on you, because literally there is water pushing down on you. Same thing Denver is called a mile-high city, which means there's less what pressure on you in Denver than there is in Green Bay? Air pressure. Why? Because just like if you go down into the bottom of the ocean, there's more water on top of you. Well, if you go up on top of a mountain, there's less air on top of you, so there's less air pressure on you. Okay? So, in terms of this, depends on the sample size. Pressure, it doesn't depend on the sample size. It depends on what is above you. Okay? What is pushing down on you. All right? So, similarities. Both are traits or characteristics. Both can be observed, whether they're intensive or extensive. You can observe them both. And the differences, ladies and gentlemen, physical properties can be either intensive or extensive. Chemical are only intensive. And then obviously going back to the definition, one depends on size and one does not. One depends on size, one does not. Yes. I will go see if there are any left in the back. Here you go, Taylor. You're welcome.
Is the quiz like energy, matter, and graphs?
What's that? The quiz is heat, temperature, KMT, and classification of matter.
When is our lab this week?
What's that?
When is our lab this week?
When is your lab this week? Tomorrow.
Tomorrow?
Tomorrow and Thursday.
I don't.
All right. So in terms of phase change, the properties are melting point, freezing point, boiling point, and condensation point. As soon as we put the word point on the end of those things, they go from being an action. Melting is an action. Melting point is a property. And as soon as we put the word point on the end, we add the word temperature at which, or we add the words temperature at which. Melting is still solid to liquid. Melting point is the temperature at which that will happen. Freezing point is the temperature at which a liquid will become a solid. What do we know about these two temperatures, ladies and gentlemen? They are the same exact temperature. Something melts, for example, water melts at 0 degrees. It also freezes at 0 degrees Celsius. The question is, are you going from the solid to the liquid state or the liquid back to the solid state? Temperature is the same though, for these and these. Boiling point and condensation point happen at the exact same temperature, ladies and gentlemen. And if you remember, we had that graph that looked like this. Up here and here, you could find the melting point and the freezing point by going over to the y-axis. You can find the boiling point again by going over to the y-axis on that graph and finding out where those plateaus were at. So that is the physical change property, okay? Or the phase change property. And then we finished with this last week when we were doing our lab signs of a chemical change, change in energy, a gas being released, unexpected color change, precipitate forms. Okay? Now, sometimes you can get fooled. Okay? Sometimes you can get fooled. I'll let you copy that down real quick, ladies and gentlemen.
What are you talking about?
What?
I'm just saying. Back in the day, they didn't have this. What? Okay, you know me too well. I don't know what's right.
Just put it all in one piece.
Well, it's 2 sheets.
Oh yeah, I guess. Just rely on memory, even though it's actually garbage.
Okay with the bathroom?
Sure. This, ladies and gentlemen, is the reaction that we did last week in our aluminum and copper chloride lab. Now, when you mix the copper chloride solution with the aluminum foil, was it a chemical or a physical change?
When we mix the what?
When you took your aluminum stirring rod and then you mixed up the copper chloride solution with it, did that end up being a chemical or a physical change? Why? What were signs that it was a chemical change?
Gas release.
Chemical change. So number one, a gas was released. Okay, what else?
Unexpected color change.
2, change in energy. Meaning what?
It starts heating up.
It released energy.
Okay, it got hot. All right, Leaf,
Unexpected color change.
what was that?
Silver and blue mixed to make it orange.
I don't eat it.
Okay, anything else?
Why is it being talking about it? Good morning. Go ahead. I don't get
Precipitate.
I don't get mood. I'm not just.
You know,
What did the precipitate look like? The orange stuff. All right. So let me ask you this for this one. If a gas is released, this is a chemical reaction up here, ladies and gentlemen. Aluminum, Al. What does the M stand for? Aluminum. No, M does not stand for aluminum. The M.
Molecular.
M.
she's just like.
You're so bad.
What?
Think about it. Aluminum.
Thinking about it.
Metal.
Metal.
Oh,
M
yeah.
stands for metal.
See,
Copper chloride. Any idea what AQ stands for?
AQ?
AQ. Aqueous. Because what did we do to it? We put it into water.
Water.
That's what aqueous means. By the way, ladies and gentlemen, this was what kind of a change?
Physical.
This was a physical change.
Because it's dissolved.
You had a blue powder, you put into water, and your water turned blue. Is that an unexpected color change? No. No.
It's not the-
No.
I thought
There was no heat, there was no gas given off, there was no precipitate formed. No. This is aluminum chloride, ladies and gentlemen. What does AQ mean again? Dissolved in water. This is why your solution went from being blue to being kind of a darkish gray color, something like that. Because there's a different substance dissolved in the water. And then this is copper metal. What color is copper? Orangish red. That was the precipitate that you saw at the bottom. You were actually making copper. Okay? So, metal, aqueous, aqueous, metal. If something was a solid, what would you put by it? S. If something was a liquid, what would you put by it?
L.
And if something is a gas, where's the gas?
Gone in the air.
No, I'm asking,
Bye.
where is the gas on the product side if you're saying we created a gas?
Probably the AQ.
AQ is aqueous. AQ means dissolved in water.
It is
Came
not
from the AQ.
Where is the gas?
Oh, in the arrow.
In the arrow.
In the air.
The arrow represents gas. No.
Oh, okay. In biology.
So where did the gas, where did the gas come from? Because I agree with you. There were bubbles in there.
I think it came from the
Chicken
the-
or
The
what?
air around it.
What?
I think it came from the liquid.
Yeah.
The aqueous one.
Yeah.
Okay, how did a gas come from something that was aqueous?
It melted.
Boiling.
Well,
You literally, in this lab, created enough heat. There was enough energy released in this reaction that it boiled some of that water. That was the gas you saw. Now, I don't blame you for claiming that a gas was created in the lab. It was. But was that a sign of a chemical reaction? When you boil water? Ultimately, it was not. Now, again, I'm not taking off because you said that in your results. But understand, sometimes we get fooled in an experiment because we see a gas being given off, but all that gas actually was boiling water. That's all it was. Okay? Now, the only way we can know that is to look at the overall chemical reaction. Okay? By the way, in the next unit, you'll learn why it's CuCl2 here and AlCl3 here. Because we'll start writing compounds next. Questions? All right, ladies and gentlemen, if you need it, take out your periodic table, get everything else off of your desk, and let's get our quiz done.
Wait, is it on online, right?
It's on the computer, but you can use your periodic table if you wish.
That's kind of embarrassing. Is it on already?
It's not. I'm going to put it out there in just a
What is
second.
that? Is that Chewbacca? Hello?
Who are you?
No.
Literally,
That's
who are
not
you?
right. So it's not on like protons or neutrons or anything?
No, none of that stuff on atomic structure is on this. No. Nope. All right.
You will do good if you stop doing that. I can't. You need to look to the invisible camera. You see if they just saw it. Because I actually think you're looking at something. I'm looking at it. We're saying.
All right, ladies and gentlemen, I just put the quiz online. Go ahead and open it up and begin. If you have questions, call me over. The first few questions need to be answered. They do not need to be answered in a complete sentence, but they do need a complete answer.
I guess I have to do it.
It says it's what?
It's no longer accepting responses.
Thank God. Because I was going to fail that.
I don't think it'd like my responses anyways.
We don't need to finish it though.
There you go.
Shoot.
Bang.
Rest of luck. There's a guy in the girl's back. There's no funny guys. Stop laughing.
Okay. The quiz is going. You need to start quietly completing the quiz on your own, please. They were always on, I just made them brighter.
Yeah, why'd you make them brighter?
Because I want you to do well on the test, and I figure you need all the brightness you can get.
Are you telling me that I'm not very bright?
Well,
I-
can you
the brightness
retake
of my
quizzes?
brain.
What?
Can you retake quizzes?
The next year when you take the course over again, yes.
Okay.
That sounds awesome, Mr. Brand.
Yeah.
But not in this class, no.
You can't do like any sort of like extra credit for it.
No. No. There's extra credit on every test for you.
Okay, that's not very helpful for me now.
Well, I know. Well, we're working the quiz, let's go.